Hello guys and ladies, welcome to the JUnit demo for Object-Oriented Software Development 3004B. So this is going to be a demo for JUnit. Included in it, you should be able to know at the end of this demo, you should be able to create a GitHub repository for yourself and use it as a Maven project in Eclipse. You should be able to also add the JUnit dependency to your POM XML file, and we will show you how to make incremental commits to your GitHub repo and to be able to write your first JUnit test case. So, all right, let's dive right in. First, I'm going to get into my GitHub repo. And I'm going to create a new repository for myself. You can see it's under my handle. This is my handle username. I can then give the repository a name. Let's say for now I can give it comp 3004 no, let me just make it JUnit demo. That will be easy. You could add a description, which is optional. So I'll go right off and say JUnit demo for comp 3004B. And I'm going to make it public so you'll be able to have access to it. It asks to add a gitignore. Gitignore is the file that Git used to know what files to ignore from the repository. For now, you don't need to bother yourself about that. For the license, we could add a GNU GPL, which means if you make any edits to this, you're obliged to contribute it back to the community. Yep. And then we create the repository. Yes, and that's it. The repository is now set up. We now have to make use of this in our Eclipse. So first things first, I'll have to, let me create my new shell, go to a new shell, enlarge that and go to my Eclipse workspace. You should have an Eclipse workspace after you finish installing Eclipse on your machine. So they should be there already. And right off the bat, you have to clone this your repository. So now we are about to clone our repository on our machine. It's recommended that you just go over this button and you can see the cloning link here. All you need to do is just copy this link. By default, you should be cloning with SSH. You could also use HTTPS if you wanted. They're both okay. But for me, I prefer using my SSH because I already have my keys all set up. If you're having a problem not knowing how to clone a repository onto your machine, GitHub has a good wealth of information on how to do that. You could just search for that. So you could just say GitHub clone repo, and that will give you pretty much very good wealth of information on how to do that. So they have the user documentation on how to do that. Read it over in case you're having problems with doing this. The steps is all here. For now, I'll just copy over my SSH link and then go to my command line over here, and I'll just say git clone and that link that drops it into my workspace. And now if I do ls, you can see it's right here in my workspace. If we go and say ls junit demo, you see right now it only contains the license, which is good. And then to confirm we're using JIT, you can then say JIT status. Sorry, we'll have to move into the directory first. So junit demo, and then JIT status, and then that tells you that you're in sync with the master branch and everything is clean. The master branch in this case, it's this. Right now we just have one branch, and we'll keep it simple that way, work with the master branch. Okay, so now we have the repository all set up here. We need to create an Eclipse Maven project out of this. To do that, we head over to our Eclipse, and then we say new project. Make sure you select the Maven project as a project you want to create. Next, I like to keep it simple, so I select the create simple project, and then this is where you need to change the workspace location to the repository you already created. And yes, that's it over here. Say open, and then you see it's the location, it's now set to the repository we just created. Click next, and then it asks you to give it a group ID. For the group ID, I prefer you give it something unique that doesn't clash. So we could give it for now 3004, and then for the artifact ID, that could give it the name of the folder we just created, JUnit demo, and that's it. So now we can finish off by pressing finish. And yes, it's created. You can see it over here. It's all there. So now we're done. We've set up a Maven project using the repository we just had on GitHub. Now we can go over and start working on the pom.xml. The pom.xml is the Maven dependency file. Here we can set up our dependencies. And since the first dependency we need for this project is the JUnit, we just type it in, give it a second. Yep, and it gives you a lot of options. Now you're all confused, you don't know which JUnit to select. Never mind. In cases like this, it's just better for you to go over to the Maven repository site and get it over there. So you can see home, JUnit 412. Let's take that option. We copy this, and then we go back to our Eclipse, and in the pom.xml, we define our dependencies here. And over here, we'll paste in that. So just a moment. Yes. Okay, so now we're all set. We now have the JUnit dependency. Now if you check your Maven dependencies, you can see it's there now with the JUnit 412 and the Hamcrest core. That's all you need, and that's all set up now. So for now, we can now start our first unit testing case. All right. Before we get into creating the first JUnit test, I wanted to show you how to make small incremental GitHub commits, Git commits, that shows the progress of how your work evolved and a history of your commits. With Git, it's possible to roll back to a previous commit or to a commit that you think worked. So it's like a repository where it records all the commits you've made, and if in the future you think uh, there's been a mistake or a bug and you wanted to find where the bug came in, you can always rewind that, go back in the history to find where the bug came in. So right now, we just added only the JUnit dependency. We've not done much, but this is an okay time to do a commit to our GitHub repository. So right now, if we go to the command line, we are in our JUnit demo folder currently. Now, if I should say ls, you should see that the pom.xml is there, which we just edited. And then if we did git status, you see that right now it says your branch is up to date with the origin master, but you have untracked files. So the untracked files are files that have been added newly to your working folder that has not yet been committed or pushed to your repository. So right now your repository doesn't have any idea of all these files. It gives you a hint. It says nothing has been added to your commit because we've not made any commit yet, but untracked files are present. Use git add to track. So now if we want to communicate to our repository that we've added some things, we use git add and we add it. You could see clearly the difference between previously when we ran it. It said nothing to commit and our working directory was clean. That was before we started the Maven project. And right after we started the Maven project, that added Eclipse added these files. So it added the project, aspat, gitignore, and all that. And then we edited this pom.xml. So right now what we'll do is say git add dot. So that means git add everything that we've edited right now. And that goes in. Now if you go back and say git status, now it tells you that the changes to be committed are these guys. So now Git has recognized that we've added new files, which is different from what was here. In this case, Git wasn't tracking these files. It just knew that they were there, but it's not tracking it. But right now we've added it. Now Git will start tracking these files, any changes to these files. So now we've added it, we still need to commit. So git commit. And then that brings up an editor for you to put in the comments on what you changed. It's always a good idea to give descriptive comments on what was changed, why it was changed, and all that. So if you were fixing a bug, this is a good time to say what bug you fixed, how you fixed it, and all that. Or if you were developing a new feature, this is where to state it. So far, what we've just done is we've just created the Maven project and we've just added the JUnit dependency. That's the only thing we've done. So right now we can now say we can now say init created Maven project. So created Maven project, and then we can now say added JUnit as dependency to pom.xml. And that's it. Once you're done, you write and you quit, and then Git creates it right now. So the commit has been recorded. If we now go back to say Git status, So now JIT has now realized that we've done a commit, and this commit is in our local repository. It's not on the central one. So the central one is hosted on GitHub. What it's saying right now is that we are ahead by one commit because we just did one commit, and this commit has not yet been pushed to the remote central repository. So it gives you a hint here also. It says use git push to publish your local commit. So now we can now say git push, and that's it. Git will now do its own magic. It will check where the central repository is, and it will push it off there. So it checked and it saw that it's hosted on github.com, and it's on my handle and in this my repository. So now if we should go back to this and take a refresh. Yes, so now we got all the files that we just added right now, and it now says we have 2 commits. We can check what the commits were, and yeah, this was the initial commit when we created a repository, and this is what we just did right now. And if you wanted to see more, it gives you more information. And then if you wanted to see what was changed, you can click on it, and then that will give you all that was changed. And what we are concerned to see right now is just the change we did, and this was it. That's it. So this is it for committing. We've now committed. Now we can go back now, and now will be a time for us now to do the first JUnit test case for our project. Okay, so we got that out of the way, and before I start with the project that we're going to use to demonstrate how to use JUnit, I would like to introduce what it is about. So it's going to be a simple arithmetic calculator that you just passed in operands to. So you could pass in 2 as an operand, and then you pass in an operator, maybe plus, minus, times, divide, modulus. Those are the operators, and then you pass another operand. So it needs 2 operands, one on the left hand and one on the right hand. And then what it does is should give you the result of that calculation, arithmetic calculation. So let's say to start it off, we have the core system that does the calculations, and then we have the UI, which we'll be using JavaFX for. We wouldn't be using the Swing because Swing is old. FX is the more modern Java UI framework tool we have, and that's what we'll be using for this project. And in your own project too, that's what you should be using. So we're going to do this the TDD way. So the TDD way is a test-driven development, which means that before you write any implementation code, you do your design and write the test case first for it. So when you write the test case, which should fail because there's no implementation for it, verify that it fails, then you write the code that implements the test case, and then it should pass. So it's a little bit different way of doing it, but that's what the doctor recommended. So let's start. We go over here in our JUnit demo project. We have the test folder. This is where all our test files should reside. So because now we think we're going to call the core of our arithmetic, we're going to create a class for it, and it's going to be called arithmetic solver. So for each and every file, you have to create a test case for it. So now we are going to create one. So we say new class, and you see it says package default. I prefer to do it under the common package. We should use a common package for ourselves. For lack of a better name, we could use something more descriptive, or we could call it core. Let's say core. Yes. And then we call it arithmetic solver test. So this is a very good naming convention. You should always end it with the test suffix. That, and then the rest is the class name, while this will be to show that this is the test covering that class. So we get that and we say finish, and then we get a file here. For every JUnit test, you have to say extends test case, and then you can see we have the options there. So you should use this guy, test case. So that's the test case class that each and every of your test class should extend, because that then it gets the benefits of using the test framework. So we get that, and Eclipse was nice enough to already import it for us. So we're all good, ready for it. And now we can now create, let's say we have, for our arithmetic solver, we have the add function. So we have to test that add function. So you say public method, public void, let's say, and for each of them you prefix it with the test add. And in this case, we just want to assert that when we add two numbers, we get what we expect. So we need to instantiate the arithmetic solver class. So we'll do that here, arithmetic solver. Let's call it solver. It's equal to new arithmetic solver. Yes. So now we instantiate the class. Notice that right off Eclipse says this class doesn't exist, but that's the intention. We're doing that on purpose, because this is how the TDD method is being driven. You first write the test before you do the implementation. So for now, we'll let Eclipse keep on flagging errors, but we know we're going to fix that later. But for now, we need to make sure our test cases fail, and then on the next step, we write the implementation that will now make our test cases go from red to green. So we got the solver, and now we can now say assert equals, so we expect, let's say we're adding 2 and 2, we expect that to give us 4. So we expect 4, and then the solver dot add 2 and 2. So that's it. Let's add one for, so we added for the add, and then now we can add for, let's say, test subtract. And then, yeah, this is going to be repetitive, but yes, that's the core thing. We add that here, and then for the solver, we then say, let's say, assert solver that subtract, and then let's say in this case we want that when we subtract 4 from 2, we get 2. Yes. And then the next one, let's copy this. Let's test multiply. And in this case, solver that multiply. And here we should get 8. That's done. Next one, let's say let's test divide. and then solver dot divide. When we divide 4 by 2, we expect 2. Just to change things up a bit, let's say I make this 8, this should be 16, and then let's say I say 9, and then 3. I should get 3 here. And then yes, next one, let's say we test, we have the modulus function. We do that, modulus. Let's say solver.modulus. And in this case, let's say 5 modulus 2. That should give us 1. And that's it. We're done. The basic test for our arithmetic solver class is done. This is the basic. As we go, we progress, we'll keep editing this and adding more text functionalities to this. So this is the basic one, and this is how we should start. Keep it simple, stupid, make incremental changes, and that's how you progress over time. So yes, now we are done with that. We should do a commit now. Let's say we go here now to say git status. So it says the source folder is now edited. So we need to just say git add all. That does it. Go again. Yes, detected a new file. Now we can commit. And then since we are working with test now, we can say added arithmetic solver test case. Send it. Now we push. And that goes over the wire down to GitHub. So now if we go over here to GitHub, we should now see 3 commits. And the last commit was this, which we just sent over right now. And it says, yes, and that's the code we just added, which was simple, bare bones. Okay, so back to Eclipse. So this is basically it for JUnit. This is how you write JUnit. That's all. To test your JUnit, you right-click on the file, run as JUnit test case, and then it tells you, because Eclipse notices there are errors everywhere, and we just tell him, yes, proceed with launch. So it proceeds, and it tells us, whoa, we've got 5 test cases, and there were 5 errors. Notice it didn't say failures, because there's a difference between failures and errors. In this case, we have an error because what we're using doesn't exist. So that's different from a failure. So we see what the failure is, what the errors are. So arithmetic solver cannot be resolved to a type. So now we go about trying to fix this. And how do we fix this? We now have to create this class. So we go over to our main Java, and then we create a new class. We call it arithmetic solver, and let's put it under the core package. Finish. We get it, and then over here we can now start saying public method. Let's say it returns a double, and let's do the add, and then it takes in a double for the left operand. and then also a double for the right operand. And then what does it do? It just returns left operand plus right operand, and that's it. Simple, done. Save it, and then go back to our arithmetic solver. You see, now most of our errors are gone. There's no more that error from this guy. So all the errors are resolved for this. Now it can find the arithmetic solver and it can find the add function. But the subtract, the multiply, and the rest are not yet there. So we have to keep pushing. Right now, to notice, if we run this test now, we should get a pass, at least one pass. Yes, proceed. Okay. So yes. So it gave us an error. It said expected 4, but got 4.0. So remember, what we used was a double, and we were returning a double. Yeah, so in this case, let's say we edit our test case now. This should be 4.0, and run, proceed. Yes, we get a green for this guy, and the rest, those are red, but that's okay. We know what to fix to get those shining greens. But at least for now, we've proved that one of our functions does work. Okay, so this has to be doubles. So let's fix this. Yes, and then we go back to our solver class. We've done add, and then now we can do that for divide, multiply, and modulus. So add, subtract. So in this case, we have this, multiply, that's done, and divide, and then we have the last one for modulus. Yes, now we're done with this, and if we go right here, there are no more errors, but now we have to confirm if our test case passes now. So we run this as JUnit test again, and yeah, we have green. So yes, that's it. Basic functionality of doing a JUnit test testing before you get the implementation in place, and then knowing that everything fails because there's no implementation, adding the implementation, and everything should go to green. And that's it. This is how JUnit works. Simple. You just asset, and that's it, done. Okay, so let's go back to our JIT, see what changed. JIT status. Okay, notice we added a new file, new main directory, and then the test also got changed. So now we can say git add all, then git commit, and then in this case we can now say test No, actually, right now it's not test because we're already done with the test. We modified it a bit, but that's not the main bulk of what we did. Bulk of what we did is added the implementation. So we say in the main folder, added arithmetic solver class implementation. And then write read done jig push. Yes, and then we have it here. If we go back over here, 4 commits, and that's it. We added it here, and we now have our green light over here. So folks, that's it. Simple as that. We got this working. So the next steps now will be to add the GUI that allows us to test this via a user interface for this. Thank you. All right. Before we go delve into the GUI, building the GUI and testing it, we should first make sure that the test cases we've written are exhaustive. It's a very general recommended uh, practice that you make sure that your test cases are exhaustive, that you make sure you test all relevant scenarios, all scenarios that are relevant to your uh, project. Uh, that being said, being exhaustive in your test, in writing your tests, it's a fine art because there's an infinite amount of test cases you could write, but you don't have the infinite time to do that. So you try to, as much as possible, to write the minimum test cases that would cover as much base, as much of all your use cases. So you have to find a balance between what makes sense and what doesn't, what you have to test and what you think is not relevant to your project. Okay, so I can give you an example of exhaustive testing here. For the add operation, let's say we now add more methods to make sure that this is exhaustive for the add operation. So let's say test add negative numbers. Okay, so we do this. And over here, let's say we now say -2, -2. We expect that to give us -4. Then we also have set equals, let's say, uh, solver dot add, and then let's say -58, and then let's say 3, and in that case we expect -55, and then also a set, let's say -1, and then let's say solver add, and then let's switch the operand now. In this case, let's say 25. This guy is -15, and then we should get 10. So this is one way of testing, and then that's for negative numbers. We now add for, let's say, for large numbers. Okay, for large numbers, we have to set, let's say in this case, we're using double. Let's say we are set that we use the maximum value and add 1 to it. Because it's Java, it will wrap around and it will wrap around to the minimum value, but we have to accept that that does happens is equal to the minimum value. Yes, and then we can still go ahead and say, let's say -5, 8, 7, 6, blah 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 blah, just some random big number. What does it say? It's out of range, of course. That would be out of range. It's still out of range. Yes, I guess. Okay. And then we do that. We should expect, let's see, what will this give me? Okay. 581. So this should give me 581.1005. Okay. So we got that done. And then test add decimals. Now let's test the decimals. So for decimal numbers, we just want to test like 5.3 and 3.3 gives me gives me 8.6. Yes, and then right here and then here let's say 333 and then here 445 and then this should be, let's say 9, so we get 12.778. Okay, that does it. What else can we test? Added large numbers, added all that. Okay, I can then show you other things because in JUnit we have various assets that we can use, not just asset equals, and then we can then also say with this asset, let's see, it's the asset not null. We can asset not null. We can asset not same. We can asset equals. We can asset let's see. There's lots of options here. You can asset false. Can asset true. So you have to use all these assets when it's necessary, when you think it's relevant to what you're testing. Let's say asset not null in this case. So what do we want to assert that it's not null will be that doing this should not give us null. And that should work. Okay. That's it. We can now run this and just to be sure that everything is still intact. Okay, we have failure. Yes, the decimals again is getting me. Yeah, and then can try again. Okay, expected 4.9. Where was this? Okay, here. On line 24. Okay, so this doesn't go over the maximum. Why is that? Yes. So, but basically, what I was trying to show here is just how to make sure you test exhaustively. Wouldn't let this bog me down for now. Let's run without that. And yes, we got all the test cases going on fine. This will need further investigation to find out why that fails. But yeah, that's the part of the life of a developer. It's to debug and see why things are not adding up. Okay, that being said, I've just showed you how to make sure you do test exhaustively. Make sure you test all the scenarios, relevant scenarios that are pertinent to your project, to your software. And because with that, then you have the peace of mind that your test cases do cover all your expected scenarios. And if your test cases are passing, it means that your software is working the way it should. So that's the peace of mind, that's the quality assurance that we expect and the use from our test cases. Thank you. All right. Let's take a stock where we are at now. Uh, let's see. So at the start, we said at the end of the demo, you should be able to create a GitHub repo. That's a check. You use it as a start for your Maven project in Elix. We've done that. Add the JUnit dependency. We've done that. Making incremental commits to your GitHub repo. We've done that. And we've been able to show you how to write your JUnit test case. Yes. So we are at this point, we are more than halfway done. We still need to add some couple of learning points here. For one, which will be should be able to create a simple GUI using the JavaFX framework library. Yes, and then we'll move on from that and test the GUI with JUnit. I think once we do that, we're able to do that, we should be able to wrap it up then. So let's go right into it. So for creating the GUI using JavaFX, JavaFX comes with the main Java core Java library, so you don't need to add a dependency, a Maven dependency for that, luckily. So we could just go right ahead and start working on that. I could have started first with a test case since we're doing TDD, but I wouldn't want, just to make it simple, I'll cut to the chase. I'll start with the JavaFX GUI right away from the bat. Okay, so we move over to our main Java, and then we say new class, and then in this case, let's say we call it the home screen. gets created. For JavaFX, you need to extend the application. Yeah, at first, Eclipse doesn't have an idea of what you're talking about, but we'll just help Eclipse here. We'll import JavaFX dot application, and in this case we need the main application. Yes, so that helps us. So that's done, but if you see there's a squiggly line here that says there's the restriction on the library. I don't know, probably some of you will not face this problem, but I do tend to face this problem here. I don't know why, but the easy way to work around this, to fix it, is you go to your project root, right click, go to the properties. On the properties, you go to make sure you're on the Java build path, and on the Java build path, click on access rules, edit, and add a accessible access rule. So we want to make sure that JavaFX with all its submodules are accessible to us. So you say on OK, OK, apply and close. Yes, and that does it. That does the magic. The squiggly line is over, it's out there. One thing I noticed is that I seem to be running on the Java 2 Standard Edition 1.5, which is old. I want to move that to 1.8. So it's still same place, go to the JRE, edit it, and let me change that to the 1.8, which is the current one. Finish, apply. Yes, that does it. We still have one error. So because we're extending the application class, the FX application class, you need to implement the methods that are abstract in it. So, and one of those methods is the start method. Okay, we will ask Eclipse to help us do this. So we just click on add unimplemented methods, and Eclipse does that automatically for us. We don't need to worry about that. So yeah, now we're ready. So we need to add a trigger that will start the GUI, and for that trigger we need the public. Let's see, no, not this one. So I need the public, I need the static method, static void main, the main method, which is like the entry point to this application. And then we use the string, taking the string args argument, and then in this case you need to launch with that. Yes, and that's it. So at this stage we have the basic JavaFX thing. Comes with the application and the stage. The stage is where you draw your canvas and all that. Let's see. So now this is the stub generated by Eclipse. Let's move in and create our panel here. So let's say pane, which is going to be our canvas. We'll go to new pane. And then from here, we can then start modifying the canvas and say canvas dot set style. So you could use the style. With the style, you can use your HTML and CSS. That's one of the novelties with JavaFX. You could use that to style your GUIs. It makes it easier, especially if you come from the world of HTML design. This will come in handy for you. So we could do this. Let's say we set the fx, you have to prefix it with fx. Fx, let's say background color to be black. Yes, now we're done with this. And for the stage, we need to add this stage, primary stage. Just a moment. So we'll, we have the canvas there. We have to create this scene. In JavaFX, there's the scene, the stage, and all that thing you have to set up. I'll go about setting it up right now. So first of all, we have the scene. Let's call it scene. New scene. And to the scene, you add your canvas, which in this demonstration, we're using the pane as our canvas. So I can then add the canvas directly there. And then we can then use our primary stage. And then set the scene to be what we just created. And then for the primary stage, we can set our title. Let's call it simple calculator. Okay, and once we're done with this, we can then tell the primary stage to be shown and to pop up that show. And that's it. We've done with the scene, the canvas, the stage. Yeah, I know it's a lot to take in, but this is the way JavaFX displays and shows its app. Okay, but before then, let's add a label. So we add a label, new label, and for this label, let's just say let's call it, let's add okay, simple calculator using JavaFX. So, and then for the label, we can then set the font. I'm just trying to show you all the bells and whistles that JavaFX comes with. It's up to you to play around, see what you can use to spice up your GUI, make it look better, look professional, and all that. So this is just things that I'm using just to make you aware of all these things around. So let's say for the set font, let's use the font property font that, and let's use the overloaded font that comes with the family, weight, and size. And for the family, we just want font let's see. Okay, let me use the serif here. Seems there. And then for the font weight, let's use the normal one. And then for the size, 20. And that's all for the front. For the level, we could then position this label on our stage. For that, we can then say relocate to 20 by 20. So we want to position it at the X position of 20 and Y position of 20. And then once all is done, you have to add it to the canvas. You always have to remember to do that. If not, it won't show up on the GUI. So we go to our canvas dot get children dot add all, and we want to add the label there. Yeah. Okay. So this at least can show us the bare bones of our GUI. To launch this, all you need to do is come over to your home screen, Java, right click, and say run as Java application. And yes, there we have it. We could do some minor tweaks here. So I could get rid of this. I don't want to set color. I want it to come with a default color, but this was just to show you how you could use some CSS styles on this. And then when we set the scene, we could already define how the size of the scene we want. So let's say we want 320 by 200. Save, and then rerun this. Yes, that came out a bit better. Okay. So for this calculator, we will need to have the operands. So let's go ahead and create the operands. I will want to clean this up a bit. So I will need to, let me clean this up a bit. Take this and just say initialize the UI with the primary stage. And then I could just tell this to create that method for me. And then over here, paste in what I just did. Makes it a little cleaner so you can follow along easily and know what each function does. Give it a sort of like break down your code into little functionalities, little features here and there. Okay, so right here we initialize UI, add this. Let's also add the operands that we will be using. So let's say for the text box, we need the text box. Text view. Yes, and then let's say left. Let's call it the left operand. Text box. Yes, physical new text field. To do that, that's done. We can then set the location for this by saying relocate. And in this case, we need the X to be still on 20, but the Y, let's push it a little bit down, so 60. And then we'll do the same for the right operand. And then in this case, we call this right. Yes, and but in this case, since that already took this space, we could make this instead of 20, this should be like, let's say 80. Let's see what this gives us for now. To add it, make sure you add it up to the canvas. So we add the left operand and the right operand there. Okay, I think we are good. Let's see how that looks. Yes, so we can see there's a bit of overlapping over there. We'll fix that next. Just okay. So next we need the operator box. So where the user can select what operator to apply on the calculator. So we need to create the combo box. So let's say we start with the combo box here. It's going to be made of strings. And then let's call it operator dropdown. So this is why it's good to give descriptive names to whatever you're doing. It makes the code easy to read and understandable. So let's go ahead and say new combo box that comes with just the strings. Yeah, so now we can now say operator get items and then add all. So add the collection of operators that can be used here. So let's say first we need the plus, minus, multiplication, division, and our modulus. So that's done. We can then locate this, relocate. So let's say, so that's 20. Let's make this 80 and seal on 60. Okay, before we go ahead, let's give a size to these text fields that we created earlier on. So let's say left operand box, let's set the max width. So probably give it 50. And so it's 50 plus 20, that's 70. So leave a space of 10 to get this at 80. And same thing here, right? Operand text box, let's set the max width to 50. Okay, so we got that now. So this is 50, 20, 70, 80. And then let's say this is about 20. Or yeah, make this then 120. Start at 120. And as always, remember to add it down here, the operator drop down. Okay, let's see what we have now. Okay, so we do have this, but it doesn't come as a default. The default is not selected, and this is still overlapping also. We need to fix that. And yes, so now we can come back over here and operator drop down that set. Let's set the item now to be the plus. Okay, doesn't seem to be the set items. Let's see which one. Set Let's see, what does this give us? Yeah, so probably set value. I'll set it to be the plus. Okay, and yeah, we notice this still overlaps, so probably move this to, let's say, 150. Then test again. Okay, looking better now. So the idea is just having something 2 plus 2, and then we should have the equals button here that gives us the solution of the arithmetic. So that should give us 4. And then the user should be able to switch around, say, okay, no, I need minus or multiplication, divide. You get the idea. So that's basically what we're trying to do here. Okay, so now we got that, and then now we need the button for the solution. So we can just say button. Let's call it the solution button equals new button, and let's give it the title of equals, and you can just replicate this to, so that's 150 plus 50, that's 200. So let's set it at 220, and then y is always 60. Okay, and then we can add it down here, the solution button, and then we can then add the result of that operation as a text box. So let's say text field, the answer text box, let's equal to a new text field. Yeah, then we answer text box, let's set the max width also to 50, and then we can relocate it also. Relocate, and then in this case, let's say 250 on 60. Yes, we should be able to add it now. Let's see how it goes. Okay, looking a bit better. Yeah, we need to reduce the space here and increase the space here, but apart from that, it's looking good. Okay, and also one thing, we need to make this just readable, only read. The user should not be able to type in anything there. So so we got the solution button at 220. We could, so that was 150 plus, so we could make it 210. Yes, and then set this to be that set editable to be false. And let's see what that does. Okay, so yeah, I cannot type in there, and the equals is there. This looks good. This looks good. So So now we are all set. Our UI is looking good. It's bare bones, of course. This was just so that we'll keep it simple. You get to understand how to do your UI GUI with JavaFX and then how to test with JUnit on this. Okay, so let's clean up our code. It's looking a bit messy here. We could see that all around here what we're trying to do is add the controls. So we could take all this and then just say add control to canvas. Then we'll send in the canvas. And that should clean it up a bit for us. So yes, now we have this here. We can then paste. Save. Yeah, looking a bit better. So now that gives us a memory of what steps we're taking here. And then one other thing, we can see there's a bit of repetition here with the position of our elements. You see 60 is repeated a whole lot of places and 20 is there. So let's create two position element. Int, let's say row 1 is 20, and then int row 2 is 60, just to clean things up. So here on our y we'll have row 1, which is the first row, and for this we should make it row 2. Okay, row 2, row 2 there, row 2. Okay, so we got that, and then let's create another one because it seems we have 50 repeated also all over the place. Text box width. Let's make it 50. And here, where was that? So change this. There was one other place, yes. Yes. So looking a bit better now. Let's see if our changes broke anything. No, everything is still working. Yes, that's good. Okay. Now we need to make the equals button do some actual work for us. So we'll continue on that. So to make the solution button actually do some actual work for us, as in what it's meant to do is to check what the operand is, what the operator is, and apply it on the operands, the left and right operands. So to make it do that, we have to add the on click event action to it. That is done by just saying solution button dot set on action, and then the action we want is the event handler. So we can now say new event handler, and Eclipse will create it automatically for us. These are just boilerplate code that Eclipse helps us with. It makes our life a little bit easier. So for this, it's complaining that it contains abstract methods, and those abstract methods should be implemented. Well, we'll just tell Eclipse to go right ahead and do that for us. Okay, so it now does that. We have the action event and everything all set up. Okay, and what then do we do in here? So over here, we can then start the whole thing. So once the user clicks on that equals button, we want to be able to know what the operands are. So we can then say the value of the string left operand is equal to the left operand text box dot get text. Yes. Okay. We could even go ahead and say change this to a double. Let's see if that works. Double the value of the string, and the string in this case will be this, and then we change this to double. Okay, and then same goes for the right operand. It is so right operand. So for now, let's just keep it simple, and let's say the what was the name for the text field, this one should be, so we have to move this down a bit, down here, just so that we have access to this answer text box. So we can then say the answer text box dot set set text, yes, should be the value of left operand plus right operand. So yeah, but it's not complaining that okay, it doesn't take the double, so because these are double, so let's see, string answer value of double left operand plus right operand, and then right here we can then switch that to be the answer. Yes, so now it looks like Eclipse is happy now. Let's test this and see if it works. So we'll add 2 and 3. That should give me 5. Yes, that's good. Okay, so time to clean up this code. We shouldn't leave this in here. We should fuck it up to its own little function. Okay, so we take these and let's say we now say set solution button quick handler. Okay, create that there and drop it in here. Yes. So, but now Eclipse says it doesn't know what solution button is. So this is where we now expose, we now create a member, we now make the solution button to be a member of this class, not just a local one, but a private one. Okay, so let's copy this, take this out, and paste it over here. Okay, that should now make it happy. Now it doesn't know what the left operand and the right operands are. Okay, take this, then take this off. Yes, and all this should be private members. Okay, then we do this for the right. Okay, and then make sure to take this one off so we are not redefining but using the member variable of the class. Okay, and then there's still the answer text box, which we have to do the same thing to. Okay, and take this out. Okay, yes, all set. And let's test again to see if we've broken something or is everything still running perfectly. Plus 33 should give me 42. Okay, cool. Okay, but now if you notice, we seem to be missing something. Let's say 5, that gives 78, but then if the user should switch to times, no, it doesn't work. And that's because we had coded the action of this to only do addition for us. So now is the time when we have to make it dynamic so that it checks what this is and kinds of do the right arithmetic for us. Okay, so we should fix that now. But to fix that, remember that we have our arithmetic solver class, which does this for us. So we should fall back on this and make sure this is what we use and not hard code it into here. So it's always a good idea to make sure that your GUIs are not smart. Make sure they are dumb. They don't know anything. They should know. They should care less about your implementation. So this is where we take out the brilliance out of it and make sure it delegates all the work down to our core methods. Okay, so over here we start with making sure we delegate now. Let's say we get the operand, and in this case, what's the operator drop down? Yes. So let's copy this, take this off, and drop it over here. Okay. So here we can then try to access that. And let's say string operator or operator drop down dot get value. So now we get the value that's selected by the user, and then let's try to use the arithmetic solver now. So we do that, and then we can then say arithmetic solver. Let's call it solver equals to the new Okay, so now we get that. And let's pretend we have a method there that does the solving for us, and all we need to pass to the solving method is solver.solve. So we pass it down the operator, and then we pass it down the left operand and the right operand. With that, we should get the answer. So in this case, our answer should be, we should just copy this. And it's this, then it's going to be the string value of that. Okay, so now we have that. But now Eclipse complains that the solver doesn't have this method that we just decided to use. So we can just tell it to create a method for us, and it does that over here. We can then tell it no, it should return a double, not a character. So return double. And then take this off. Okay, so now we have the operator, we have the left operand and the right operand. We should just make sure that we send those across. And I don't like the class double. I want to use the primitive type. I prefer using the primitive type. Okay, so let's add a switch statement on this. So for the switch, and the key is going to be the operator. And based on the operator, if it's a plus, we then say add the left operand with the right operand, and yeah, we get that. And let's say the double answer is equal to 0 for now, and then let's indent this. Okay, so at the end of the day, we just return that answer. Okay, and in this case, the answer will be this. Yes, and then copy this. Yes, and then for each of those cases, for the case of the minus, we do the subtract. Yes, and then this is the case of the multiplication. We should do multiply. And then for the case of the division, we should do divide. And in the case of modulus, we should then do modulus. Yes, and that should be it for us. So see how we delegate the function back to this guy. And then right now, it should work, hopefully. Let's test it out. Okay, so let's say 23 by 3 is plus is 26, and then when I switch that to minus, what does it give me? 20, correct. When I switch that to multiplication, what does it give me? 69, correct. When I do divide, it gives me yes, that's correct. And then when I go to the modulus, what do I get? 2. Yes, so perfect. We're all set with this. Um, so far, we seem to have been able to use JavaFX to create the GUI for our arithmetic solver, and we were able to demonstrate that we're able to pass in the values and everything works. Just to show you that for everything there needs to be validation. In this case, let's say we are doing this works. But what of the case where the user now decides to type in not just a number but mixture of it? So this is going to evaluate to be a string, and when you try to do that, you see that's the error that pops up. For this demo, I'm not going to go into validating your user input and making sure that everything stays kinky and good. I will gloss over that. That will be a challenge for you if you're interested to fix and know how to make sure that your GUI accepts only valid inputs. That's an assignment for you if you want to take that up. That apart, we'll now move on. Okay, so this is done. Just to take out those red things out. I don't like seeing red. Yes. Okay. So far so good. Remember that we've done a lot of work, but we've not yet pushed to JIT. And it's always a good idea when you do little sums of work, you push it out to JIT. But in this case, we've done quite a few, and we've not committed any of our work down to JIT. So let's check our status right now. So we can say JIT status. Okay, so there's a lot of changes here. And this is a good part where you learn how to slice and dice your commits. In the past, we would have just said git add all, and that will add everything. But for now, no, that wouldn't be a good thing to do because we've done disparate, different types of work here. So now let's see. For the first one, we did the solver and the test. Let's see what was changed in here. So if you want to see what was changed, you just copy the file name and then say git diff with the name of the file. Shows you what was changed. So added the solve function, and then for the other one, let's see again. So git diff. Let's see for the test, what did we change? Okay, so we added more exhaustive testing to this. Okay, so let's start with adding this. So we can now add separate commits. So let's do this. Git add this guy, and what were we doing this? We said git commit test. Let's say add more test cases for add method. Yep. So we can write and quit. Yes. It's also a good thing to check the log and see what has been done. So this was at the beginning. I know this the last one I just made, but this was the initial commit here. And you can see how it evolved all the way down there. So we just added this right now, and then we can then go back and say JIT status. Okay, so then we added this guy, JIT add this. Then we can commit that. It's in the main folder, and then we create calculator home screen. GUI Java FX. So you see how descriptive that is. We can commit that, and what we still have. Okay, so now we are left with the solver thing. So now we can then say JIT add all, and then JIT commit. And then say in the main add solve method. For GUI usage. Okay, we're done with this. And now if we see JIT status, okay, now we no longer have any changes, but now we are ahead of our JIT central repository by 3 commits. So now it's a good time to push. But before then, we can also look at our JIT log, and then that shows you all the changes, commits we did. Okay, so JIT push. And now we've pushed down to GitHub. And if we are to check GitHub, let's see. Okay. Seven commits so far. And then if we check what the commits are, yes, it shows everything we just added right now. Okay, so yeah, there you go. You get how to slice and dice your commits so that you make it a piecemeal of the work you did. So there's a genealogy of the work you did, and it's in little piecemeals that can be pieced apart. Makes things easier, makes it cleaner on the progress of your work so far. Okay, that's it for that. All right, so now we're done with the JIT push. I just thought that we should maybe get to know how to do JavaFX animation. So I would like to throw that in to the mix of what we're going to achieve or learn in this demo. Okay, so to introduce you to how JavaFX animation works, let's say we start from, yes, from here. And in this case, we added the controls to the canvas. We could go right on and say set up cards animation to this canvas. And then we'll tell Eclipse to, yes, create the method for us. So over here, first things we'll do is let's say we start with the cards. We want to display a card on our canvas pane on the scene. So let's say we now get in the image class, call this image, set it to be the new image, but the image needs the file input string. So we could initialize a new file input stream here. Let's say new file input stream. Yes, and the file we want to add here will be the image of a card, maybe ace, spades, or knights, anyone. For now, I will have to import. Let's see. Yes, I will have to import one of my cards. So you go to resources. Basically, this is where we are. This is the JUnit demo we're working on, and this is the source folder. Under the source folder, there's the main, and under main, there's Java and resources. This is the way Maven sets it up for us. You could see that over here you have the source, main, Java, and we'll have the source, main, resources. So that's it here. Source, main, Java, source, main, resources. And in this case, it's a good idea to add all your asset files, your images, your movies, or anything to the resources folder, because those are assets that should be on the resources. So let's say I already did add one, and basically I'm following the convention that we have the core package here. I'm trying to say that all the resources I'm adding, I break them, categorize them by the package. So in this case, we have the core folder, and the core folder is where I added the Snoopy. This is a card that I want to add, display on the JavaFX GUI we just created. So just a bit of organization. Let's say I create a new folder and let me call it cards, and pull this in there. Yes, so now in the cards I have this. So I could reference that here, and basically I'm going to do what we call the relative path. So it's not going to be an absolute path, it's going to be relative. So the relative means it's relative to our main project directory. It's going to be source, main, resources, core, paths. So source, main, resources, core, cards. I hope I got it. Yes. And this is going to be Snoopy1, Snoopy1.jpg. Okay. Now we got that, but Eclipse is complaining that there's the unhandled exception for file not found exception. Yes, in this case, we could decide to tell it to help us surround it with a try catch block. So we'll have the try catch there, and let's say this goes ahead smoothly. In JavaFX, you need to embed the image in an image view. I know it's not straightforward, but that's the way JavaFX works. You have to initialize the image view, and let's say in this case we have image view to the new image view, and then in here you can then say your image view dot set image, and then that will be the image we just created over there. Yes. Another complains that it doesn't have the variable image. That's because this was surrounded in a try catch block. Let's initialize our image here, probably image, and make it null. And over here we take out this. So yes, now we are good. And since we are done with this, we can then set the relocate image view dot relocate, and let's say 20 to 180. Okay, and now we have to add it to the canvas. So just like we did down here, we have to say canvas to get children. You get children, add all, and then we add the image view, and that will do it for us. Okay, let's see what we created so far. Yay, we have it here. Okay, there seems to be a bit too much space down there. Let's see if we fix that. So let's make this, let's say 140. And then the size of the canvas, probably this is, so it's width by height. So let's increase the height to, let's say 400 and try again. Yes, so it looks a bit better now. Still needs a little bit tweaking. Let me change this then to 120. Okay, here we are. So let's see now. This is done. Next thing we want to do is that we'll probably want to animate that and try to make it so that there's some bit of animation in there. Also, one other thing I would like to do is for the cards, right now we just have one card. It would be a good idea if we have several cards and attach some handler, click handler on that thing, on the image, so that once you click it, the card swaps around randomly. That would be one good thing to do. So for now, let's see, which do we tackle first? Let's handle the animation first. Okay, so in JavaFX, there's the animation timeline and the keyframes that can be used to do this. Let's say we set up a timeline equal to new timeline, and then all right, so say set the auto reverse property of this timeline, and let's say it's true, and then timeline dot set the cycle count to timeline dot indefinite. So we want this animation to run indefinitely. Okay, now we have to set up the keyframes. So for the keyframe, we do the new keyframe yes, and then over here we get the sorry, before we do the keyframe, we have to first initialize the key values. Sorry. So for the key values, now set in the new key value. I want it to be this, and the writable value should be uh, uh, duration that let me see. Okay, instead of using the duration in this case, let's use the x value of the image, x property of the image view. So we could pull up the image view, get the x property out to be the starting point, and then for the end value, let's say for now put 200. The interpolator, JavaFX comes in with the interpolator that allows it to calculate the interpolated values for the animation time frame. So we could use this and tell it to ease on both sides. Yes. And once we're done with that, we can then go over and use the keyframe. For the keyframe, we can then set the duration of the animation, each cycle of the animation, to be, let's set it in milliseconds. Let's set it in this case to be 500 milliseconds. And then for the values, we'll use the key value that we just generated. So that was the point of creating the key value in the previous step. So now once we have this, we can then go over and use the timeline. Let's say get the keyframes for the timeline, and to that we want to add our newly created keyframe. Yes, and then now we can then say timeline.play to run the animation. Okay, let's see what that gives us. So okay, so this is it. It looks a bit jittery. Let's reduce it, make it slower. 800 milliseconds. Let's see if it can cope with that. I think I have a lot going on my machine, that's why it's a bit jittery. Yes, and then we have it here. One thing I can do now is also increase the size of this, the width. Let's make the width, let's say 380. I think that will make it look better. Yeah, a bit better then. Okay, so we are done with this. We've now added an animation, basic animation to our image view. This might seem a little bit fuzzy, but I'll go over the steps one more time. So first you create your image, set where the image file is. In this case, we're using our cards. Then you create an image view. And for the image view, you apply the image you just created in the previous step, and then locate it to somewhere on the canvas. And then for the timeline, which we use for the animation, you set whether you want, there are different properties you could use here, auto reverse, cycle count, and all that. So we set up all this. I think a good resource for this should be on the Oracle site. You can see this is for the JavaFX animation. You could go there, see a lot of all the animation properties and methods they have. You could read up on any of this and see how it works. Like the fade transition, you could look into it. gives you a bit details of how it works and how to use it. These are examples that you can use. So yeah, play around with it, see what you can come up with. Go crazy with it. Okay, all right, all right. Let's spice things up a little bit. Let's add a click handler for our image view so that once the user is able to click on the card, let's say we switch it with some random card. So to start with that, we need to get more cards to be added to our deck. For that, I already have some cards that were here. Let's see. Yeah. So I have all these cards. Let me select all. Paste in here. Okay, so now we have a bunch of cards, and then we want to be able to swap these cards around when the user clicks on the card view. Okay, so for that, we need a way of loading in all those cards, and it will be very tedious for us to load each and every one of them individually. So let's say for now we create a file directory view for this. Let's see. So if we create the file, I call it the cards directory to the new file, and the path name to this will be as before. It will be source main resources core cards. Yeah, so we already have that here. Copy that, paste over here. There we have it. So let's create a filter for this because we want to prevent so that if someone adds a different kind of file here, let's say an Excel file, CSV file, or anything, we don't try to load that as an image. That will cause an error. So just to prevent against that, let's have the file name filter right here. So let's name it image filter. Yes, and then you see the Eclipse already created a boilerplate for us, which is very handy. So in this case now we can then say return name dot to string to lowercase that ends with, in this case, let's say all our file structures for the image for the cards ends with JPEG. So we put it here, JPEG. There we have it. And then we can now get the card images. So now we can now say file cards image is equal to the cards directory dot list list it with this filter. So what that will basically do is go into the directory and filter out all the files that end with JPEG and return it as a list for us. Okay, and here what does this return? An array of string here. Okay, so list files, and then here we can pass in the image filter we already created. Yes. from string to file. Okay, so Eclipse seems to be giving us the error that it can't convert the string to file, because basically it looks like this function returns a string instead of the file we need. I guess we're using the wrong function, and we could switch that back to, I think, list files that uses the filter. So in this case, we use list files, and our filter is the image filter. And Eclipse still complaining? Yes. So this returns an array of files, not just one file. So we need to convert this to an array too. And yes, here we have it. So this should be the cards file. And then in the next step, we need the image. So basically, we're going to convert all this cards file to the cards image that can work with JavaFX. So cards image, let's say, since this is giving us an array, we'll also need this to be an array. And it's going to be new image. And for that image, so it's going to be an array of the cards image. For that, it's going to be however large this is. That's going to be the determining size of what this array is. So we can then say cards file dot length. Yes, and we're done there. Okay, now we need to loop over the cards file and convert it to the images we want. So we can then say for each of these files, for each card file coming out from the cards file array, we want to convert it to the image. So we already have the image array. We can use that. And we need an index for this array. For that, we can initialize one over here. Let's call it int index, start it from 0. And over here, we can then put in the index for this array and say new file, no, new image with the input string. So we got the image, and then now we can then convert the file to the image. New file input string, and this is going to be the card file dot we get the path to that file. So once that is done, we should be set. Okay, so we need to surround with a try catch. Yes, that's surrounded now, and we get that out. Yes, and once that is done, then we can get rid of this, because this is the implementation we did for just one image. Now we have the implementation for all of the images that's in the folder, in this folder, all of it here. Okay, so take this off. Before we take that off, before we take that off, we need to be able to also set, since we have the array here, that means in this case, we, instead of that, we'll be setting the first one. So this will be changed to cards image of value 0. So the first one in the array is what we'll be setting to that, and that should work. So now we've got the array of the cards, We've set the first item in the array to be what will be shown there. Let's see if we are still on track and if everything still works, just to be sure we haven't broken something yet. It's always a good idea to code in piecemeals. Okay, so yeah, still works. And does our calculator still work also? Yes, that still works. So everything is still in place. So now the next thing we'll be doing is to switch the images. So once the user clicks on this, we want to be able to switch randomly, pick one other card and replace it here. Okay, let's see how we do that then. So for that, we can then decide to, okay, this is no longer needed. Yes, for that, we can then decide to say set card click handler. So that we'll be able to manage the click handler for the cards handler. And in this case, what do we pass to this? Nothing. We can then create the method for ourselves here and then over here. In this case, we need to make the image, this image, to be accessible to us everywhere. So we need to copy this, take out this, and then paste it over here, private. Since we're going to use it somewhere else apart from where it's being initialized. Okay. Yeah. So now we can then say we also need the image view because the handler is going to be on the image view. Okay. And let's grab this. And paste over here too. We got that there. And then now we can then say image view dot add the event handler that we need. Let's see. What event handler should we be adding here? Okay, so the event we're interested in capturing is the mouse event for the click. So we should be able to change this to mouse event and try to capture the mouse clicked event. Yes, and that's it there. And this should be the event parameter to which we could create an anonymous function to handle that. So now what do we want to do? We want to randomly select an image from the array we already had. First we need the random generator. So we can create one. It's equal to new random generator. I think it's best to put this outside the event handler. Okay, so now we get that, and the random image we want to get, let's say the image, random image. is going to be from this array, from the cards image array that we generated earlier. So for the cards image, we should be able to say rand dot next int, generate a random index out of that. And for this, it will be the size of the bounds will be the size of the array. So cards image dot length, and there we have it. We have our random image, and now we need to update the image view with this random image. So image view dot set image, and then we set the random image there. Yes, and this should do it for us. So let's test and see that this fulfills our needs. Okay. There's nothing there. Let's see what happened. So our cat's image, we got a random one, but seems to be null. Let's see. Okay, now I see what the problem was. So remember we had the index we were looping on in this for loop, but we were not incrementing the index count. So that we need to do. If not, this will always be 0. So we need it to increment from 0, 1, 2, 3 till it exhausts the list of the files in that directory. So without this incremental, that means we always set it to 0. So let's fix that and see if it helps our situation. Yes, yes. Now we have an image that's outside the bounds of our scene. And now it's back. Okay. Okay, so we have to fix that. Let's see what we can do for the image view. So for the image view here, we located it. Then here we put image dot image view dot set. Let's set the fifth width to be maybe 300, and then set the fifth height to be 400. Once we do this, it will sort of like stretch the image. We don't want that. So let's make it so that, say, preserve ratio property, and we want it to be true. Okay, not that. Maybe set yeah, set preserve ratio property, and that should be true for us. Okay, now let's run this again. Okay, looks like I made it too big. But let's see. Yes, yes. Looks like it's working. Okay, yes. I could have fun with this all day long. Yeah, okay, so this is now done. Let's see if we could make it a bit fun, like the whack-a-mole game. Let's see if you can, if we reduce the size of the width and the feet. Let's see what that gives us. Okay, now it's faster. Now try to change that image. Nope, 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 nope. Yeah, so that's the internet thing I needed to show the game around that. So yeah, now let me put it back. Let's say 150 by 200 and see again. Yes, now I'm having better luck with changing the image. Unlike before when it was too little and it was like catching the mouse in the act. Okay, so yes, we're done with this. And all right, so now we're gonna do an introduction to Log4j. We're doing this introduction to Log4j because you'll be using it in your projects, and it will be handy because with Log4j you could log what your application is doing, and that could serve as a proof of correctness for your application. So Log4j is a logging tool for Java. It's meant for logging things on your app, either for production or for testing or for debugging. You could see what, just to get an idea of what your system is doing. So to to install Log4j, because we're using Maven, it's rather simple for us. All we need to do is get the Maven dependency for Log4j. We'll head over to the Log4j site, which is here. Then you can see the Maven site there, and all we need to do is copy these dependencies. Okay, so we copy that, come back to our Eclipse and go to our pom.xml. Yeah, and in our pom.xml right now, the only dependency we have is the JUnit. We'll add on that and add the dependency for the log4j right over here. Yes. Okay, so we can see that the dependency for log4j comes with the API and the core. So they separated it into two packages, but that's okay. Once we get it there, we should now see in our Maven dependency that there's the log4j now. Done. Okay, so the next thing then we do is we have to make use of the log4j in our classes, especially in any class where we want to uh, do some logging, trace logging and all that. So let's close this and let's say we come over to our home screen.java and we want to do some logging here. So first you have to define your logger here, and private static final. Yes, and you have to use the logger here, this one. I think. And then let's call it logger. New logger. Oh, oh, sorry. This was the wrong logger that I picked up, I guess. So let's say logger, the class, yes. Uh, just a moment. Okay. All right. So we need the logger interface, not the logger class itself. So it's going to be logger, and that's the interface. This let's call it logger. And then because it's an interface, we need to get the factory out of it. So let's use the log manager from log4j, not the one from Java util. So make sure you use the correct one, the one from log4j, and then you say get logger with your class, and the class name will in this case be our class, which is home screen dot class. Yes, and once that is done, that's set, we now have log4j working. So right now the main thing is can now start logging your application. If you notice, this thing has to be private static final. Final because it cannot be changed once it's been defined, and static just so that log4j is able to use it and manipulate it without instantiating your class. Okay, so this is the launch pad of our application. This is where once you click start, this is where it goes through. Now let's put a log there. Let's put a log there and say logger.log. Let's give an info level message, and then we'll keep our message here. Home screen booting up. So this is how you log in log4j. So you just use that, and you can then say passing the message you want. With log4j, there are other different types of levels of messages you could log. In this case, we logged info, but you could log, let's say, error. You could log trace messages. You could log information, info messages, and you could do some debug logging. So these are just different levels for log4j that states how important or how critical this message is. And then you could have different rules in your log4j to say, okay, uh, warning messages go to some certain files, error messages go to some other files. So you could define your output based on these warning levels. It's all up to you. Okay, so let's be done with this. Now, if we run our application, we should be able to see the home screen booting up. So run. Okay, so now we get an error message from log4j. It says that there's no configuration file found. Now for log4j, you need to have it comes with configuration files in XML format, even in JSON, and the properties file format. But it's normally recommended to use the XML format. Uh, you could I have one sample XML format for me here, which I can just copy right away and use. So let's say I copy this. Now you have to make sure you go into your resources uh, folder and create the XML there. So you go to order and we want to create an XML file, and the name you should give it is log4j2.xml. So this name has to be specific. The file name has to be specific because in this case we are using log4j2. We should be using log4j2, not the version 1. The version 1 has been retired since 2015. It's pretty old. So the current version is log4j2, and that's what you should be using. And make sure to name the file log4j2.xml. Finish. And we paste in our configuration file. So let's read over what this configuration file says. So it says that the log path, our log path should be logs. So it's going to create a directory called logs in our root folder. And for the archive, it will create it under the logs folder also. The archive is when to archive old log files, it will move it down there. Now for log4j, there's what we call the console appender. So this is when you want your messages to be coming out in the console. This is like the console. We have the file appender. That's when you want to be writing your log messages to a file. We also have the rolling file appender. So basically this tells log4j that there's a certain threshold on what to log to this file. In this case, the threshold is based on the size. So once this file is above 30, approaches 30 megabytes, what log4j will do is it will rename this file, archive it, and create a new one. So it doesn't overwrite, it doesn't keep overwriting the same file. This is the one that overwrites. So once this is full, it overwrites. But for this, it will cap each file at 30 megabytes and create a new one. Okay. Sorry for the misinformation. This doesn't overwrite. This just keeps writing to the same file. But you could then run into the situation where the file becomes too large, and then it becomes not so easy to open the file and read it. So yeah, so that's why the rolling file appender is better than the regular file appender. Okay, so once that is done, you need to, in the loggers section, you need to define what all the loggers you want to use. And in the root, you have to state it here also. So that's that for that. Let's go back to our home screen and try to run it again. Yes. Now we see the message. Now we see the message here that says home screen is booting up. So we can trace what all that's going on in our system. Now, if we should refresh this, we should see that the log folder was now created. Let's refresh. Yes, and here we have it. And if we look at the rolling file, it's there. So now it will be writing it to this file. Also, at the same time writing it to the console. And that's because we defined here that we want the console appender and the rolling file appender at the same time. So yeah, now we can go crazy, start logging every important details we want here. Uh, let's say what we want to log is we want to log when the user tries to select an image. Click on the image. So here we could then say logger.info Then we could say card click detected. Okay, save that. And then we could also look for the solution button solver. And over here, we could then go and say logger.info and then say solving button clicked. Now, if we run our home screen again, we should see all these messages in our console and in the file, in the log file. So yeah, this starts. If we click on here, yep, card click, yep. So we get that, and then if we do 2 plus 3 and say equals, yeah, so solving button clicked. So this is how you log with log4j. Now there are other things we could tweak with log4j. You could see that because we're using the info, it tells you that the level here is info, and then it comes out with a date timestamp. You could tweak that around if, for say, probably you don't want to see the hour, minutes, and second. You could change that. So let's go right here. We'll take this out and run the home screen again. Yes. So we now see that it now comes just with the year, month, and date without the time in there. So those are little tweaks you could do around your configuration file for the log4j. This should help you keep you going and running with log4j. So yeah, this is it. We're all done. Just before I sign off, let's see if we can do a commit. Okay. So let's slice and dice this commit. So let's add git, add this git commit. And remember, in this case, what we did was we added add card animation and click handler. That's what we did in this case. And then for the rest, if we add the rest of things, we commit. And then in this case, we added logs. So add log4j dependency, Maven dependency. And card images. Yes, so this is what we did here. And then we can then say git push. One thing you should always remember is that if you're working in a team, you always have to do git pull so that you don't have conflicts. Resolving conflicts in git is quite easy, should be straightforward in case. So a conflict normally happens when your team member already made a change to a file and you didn't pull in the changes, but went right ahead and made a change to that same file and decided to push. Now JIT will see that and say, okay, your team member was the first one to edit that file, his changes conflicts with yours. So JIT would now tell you to fix the conflict yourself. So you have to decide which change should go in and then push. So now we can do the JIT push. And it should go. So yes, that's all for now. Uh, just to make a recap of what we've done so far. So last time we stopped at writing the JUnit test case. Now we created a simple GUI, the calculator one. This is done now. For testing the GUI with JUnit, we didn't do that. We skipped over that. That will be done in some other video, not in this. It would take too much of our time to do it right now. But instead, we did the JavaFX animation. And then we did log4j. In for logging in Java. So yes, at this time, I will now be signing off and hope that you've learned from this demo. Thank you very much. Okay.